Okay, these are the review pages for Chapter 6. I'm just going to go through it so you can see how it's done. Okay, estimate each product. So what we're going to do is we're going to round any decimals to whole numbers. So $4.80 is close to $5, so you're going to go 5 times 5. So the estimate is $25. And then here, 3 and 3600ths, that's closer to 3 times 4. 4 is already a whole number, so we're not rounding it. So 3 times 4 is 12. That's the estimate. 10 and 8/10 is close to 11. So 11 times 7 is 77 for our estimate. All right. Multiply, check for reasonableness. Check for reasonableness is it means you're going to estimate just like we did here, and then you're going to compare it with your multiplication. So first let's go ahead and estimate. So if I estimated, it would be 6 times, that's close to 2. So 6 times 2 is 12. So now let's do our multiplication. We multiply, treating them like they're whole numbers. So instead of 1.8, we're going to treat it like it's 18. 18 times 6, so we do 6 times 8, which is 48. Carry the 4. 6 times 1 is 6 plus 4 is 10, so it's 108. But since my estimate is 12, I know that decimal has to go between the 0 and the 8, because that would be closest to 12. If I put it here, that would be close to 1, and if I put it here, that would be close to 100. So I know the decimal is going to go there. So I'm going to go ahead and put it there. The other way to tell where the decimal goes is count the decimal places to the right. So we see there's one decimal place to the right. There are no decimal places here, so there's only one decimal place. So you go to the end of the answer and you go back one space. All right. So let's do that again. So here we're going to estimate first. This is close to 5 times 5, which is 25. So now we multiply. We got 30, carry the 3. 20 plus 3 is 23. And since I know my estimate is 25, then the decimal must go here. 23.0, I'm going to go ahead and clean up my answer. I don't need a 0 and I don't need a decimal there, so that's just 23. All right, this is close to 7. This is close to 2. So my estimate is 7 times 2, which is 14. Whatever my answer is, it's got to be close to 14 when I'm done. So I'm going to treat this like they're whole numbers, like that's 716 times 21 when I do the multiplying, and then I'll place the decimal at the end. So 1 times 716 is 716. Done with the 1. Now I go to the 2. Since the 2 would be in the tens place, then that would be, I would put a 0 here and then multiply by 2. 2 times 6 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 7 is 14. Then I add the partial products. I got 6, 3, 10, carry the 1, 5, and 1. Now I count my decimal places. There's 1, 2 here, and 1 here. So that's a total of 3 decimal places. I go to the end of the answer and go back 3 spaces. 1, 2, 3. So there's where my decimal goes. I check the reasonableness. This is close to 14, so it works out. It's reasonable. To these, we're going to use the properties of multiplication to make a better strategy for multiplying these mentally. So what I would do is I would switch the parentheses to multiply 50 times 20 first. And then multiply it by 1 3/10. That makes it easier for me because when I multiply 50 times 20, I'm going to get 1,000. right? So when I changed the parentheses, I changed it by grouping it differently. So that's the associative property. So that turns this into 1,000 times 1 3/10. Now, we just learned how to multiply by powers of 10. So when we do that, if we multiply this by 1,000, we move the decimal 3 spaces. So we're going to move it 1, 2, 3, right here. Wherever there's an empty space, you should put a 0. So our answer is going to be 1,300. Okay, again, for number 14, I could do it this way, but if I wanted to do this mentally or make it easier on me, I wouldn't put these two together first. I would put these two together first. So I'm going to rewrite it, putting the parentheses around 2 times 50, because I'm going to do that first, and then I'm going to multiply it by 5 6/10. This is much easier because I know that 2 times 50 equals 100, and it's easier to multiply 100 times 5 6/10. So I take 5 6/10, and I'm going to, if I multiply it by 100, that means I'm going to move my decimal 2 spaces to the right. So 1, 2, goes there, which means I'm going to have to put a 0 here. So the answer becomes 560. And what property did I use? Again, this was the grouping property because I just grouped the numbers differently. I didn't change the order of them. I just grouped them differently. So again, that's associative property. Okay, estimating quotients is a very important skill. So the first thing we do when we estimate quotients is we're just going to go ahead and get rid of the decimal because we really don't need it. Any decimals in that is less than the value of 1, so it really doesn't affect the number that much if I just take off the decimal when I'm estimating. So we're going to change this to 20 divided by 4. Now 4 is already compatible with 20, so this is an easy one. So 20 divided by 4 is 5. Okay, we're going to do it again. So we're going to go ahead and take off the decimal. So this is 24 divided by 8. And again, this is already compatible. So 24 divided by 8 equals 3. Now this one, if I take off the decimal, I'll get 118 divided by 10. And I want to make this number compatible with 10. So the best thing to do would be to make this into 11 tens or 12 tens. This is closer to 12 tens, so I'm going to round this to 120 because it goes along with dividing by 10. So now this makes it much easier to divide. I have 12 divided by 1, which is 12, and I have 1 0 minus 1 0 is no zeros. So there's no zeros left. The answer is 12. Okay, the first one we're going to divide is a power of 10. So dividing by a power of 10 is again going to be shifting the decimal. So first thing you should always do is convert any powers of 10 into the value. So 10 to the second power is going to be the same as 100. So we're going to divide 102.6 divided by 100. Now, just like multiplying by powers of 10, we shift the decimal. But since we're dividing, we're going to move the decimal the opposite way. And since the number would get smaller if we divided by 100 or 10 or 1,000, we know that the decimal has to move to the left now. So we're going to move 2 spaces to the left. 1, 2. So it's going to end up right there. So the answer becomes 1 and 26 thousandths. we're going to just do long division. So this is the dividend. That one goes in the house. And 8/100ths is at the door. Now when we divide by a divisor that has a decimal, we're first going to do what it takes to turn this divisor into a whole number. Now what we'd have to do is we'd have to multiply it by 100 to get this to be a whole number. That would move the decimal over twice. Okay, whatever we do to the divisor, we also have to do to the dividend. So that means we have to move this decimal over twice, which means that we will also multiply it by 100. So move this over twice, move this over twice. So since there's an empty space here, we're going to put a 0 there. And now we can begin dividing. So we say, does 8 go into 1? No. Does 8 go into 18? Yes. How many times? Twice. 2 times 8 is 16. We subtract and we get 2. Is that okay? Is that an okay answer? Yes, it is, because it's lower than the divisor. So then we can bring the next number down, which is a 0. Every time we bring a number down, it means something has to go above it. The answer to what goes above it is how many times 8 goes into 20. 8 goes into 20 twice. 2 times 8 is 16. And now I have 4 left. 4 is okay because it's less than the divisor. I'm out of numbers, but I have a decimal here. I'm not going to have a remainder. I have a decimal here, so I can add another 0 because I didn't change the value of this number. Now that I have a 0 to work with, I can bring that 0 down. And now I have 40. How many times does 8 go into 40? We're going to bring the decimal straight up. 8 goes into 40 5 times. 5 times 8 is 40. And that's it. All right, 23 has a couple of steps in it. So let's go through this process. It costs $4.25 for 1 pound of roast beef. How much will it cost to purchase 2.5 pounds of roast beef, or 2.5 pounds of roast beef, right? So it says to round to the nearest cent if we need to. So let's see. We are going to, for 1 pound, it's $4.25, and we're going to purchase 2.5 pounds, which is 2.5 pounds. So we're going to do this 2.5 times, basically, is what we're doing. So we're going to multiply 4.25 times 2.5. All right, decimal multiplication. Let's do this. Okay, so right now we're going to ignore the decimals, and we're just going to treat this like it's 425 times 25 to do our long multiplication. So we got 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. Put the 2 down, carry the 1. 5 times 4 is 20, plus 1 is 21. And now I'm done with the 5 multiplied by 425, and now I'm going to go to the 2 and multiply it by 425. Now this 2, if we're treating this as a whole number, isn't really a 2, it's actually a 20. So if we were multiplying by 20, we'd have a 0 and we'd put the 0 at the end. So we're going to go ahead and put the 0 there, and then we're going to start multiplying. So 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 4 is 8. Now we're going to add these two partial products. So we have 5, 2, 6, and 10. Okay, remember there's 2 ways to place the decimal. One of them is the procedural way, where you count all the digits to the right of both factors. So we have 1, 2, 3, which means we would start at the end and we would count back 3 spaces. 1, 2, 3. The other way we could have done it is we could use, since we have to estimate anyway, go ahead and estimate. So this is close to 4, and this is close to 3. So 4 times 3 is 12. All right, now think. Where would we have to put that decimal in order for the answer to be close to 12, the closest to 12? So we put it here, that would be ridiculous because this would be 1,062, right? And if we put it here, it's still kind of ridiculous. That would be 106. That'd be close to 106, which is not close to 12. If we put it here, now we're looking good. That's about 10. That's about 11, and 11 is close to 12. If we put it here, now we're getting away from our answer again. That would be close to 1, and 1's not close to 12. So it definitely does go here. All right, now we're supposed to take this number and round it to the nearest cent. Now, if this was money, cents would be right here, 62 cents. And now we have to round it to that one. So we look at it, it's 5 or greater, so the cent goes up by 1. So the answer we're actually going to have is going to be $10.63. So answering the question in a complete sentence, it will cost $10.63 to purchase 2.5 pounds of roast beef. Okay, number 24, we're looking for a pattern, and we're going to use the pattern to figure out what the next two numbers are. So if I look at 41 hundredths, and the next one is 82 hundredths, I can already tell that 82 hundredths is twice 41. So it's this times 2. And if I look over here, it looks like this 164 is this one times 2. And then it looks like that 328 is this one times 2. So it looks like the pattern is you're multiplying each consecutive number by 2. So that means in order to get the next two, I just have to multiply this one by 2, and then whatever I get there, I have to multiply that by 2. So I'll go ahead and do that. I have 3.28 times 2, and I get 6.56. And now I have to multiply that times 2. And we get 2, carry the 1, 10, 11, carry the 1. 12 plus 1 is 13. I have 2 decimal spaces, 2 decimal spaces. Also, I can estimate that's close to 7. This is 2. 7 times 2 is 14. In order for this to be close to 14, the decimal would have to go here. So the next number is 13 and 12 hundredths. Okay, reading this problem, we have to figure out what's going on in this problem and what operation we're supposed to use. So it says the total bill for the dinner party was $113.58. If each person pays $12.62, how many people attended the dinner party? Well, let's see what that would look like. If I drew a bar model of that, the total amount of money we're talking about is $113.58. And the question is asking if each person pays $12.62, how many people will there be? So if this is one person paying $12.62 out of the total, then there's going to be another person paying $12.62 out of the total. And it's just going to keep going until all the money has been paid. So we were trying to figure out how many people, 1, 2, and how many total people it will take in order to pay for all of this money. Well, this is essentially asking how many times does this amount fit into 113.58. So how many times does a quantity fit into another quantity? Well, that operation is division. So we're going to divide these two numbers. I'm going to go ahead and do that on another piece of paper because I need more room. So we're going to divide 113 divided by 1262. All right, we got dividing by 4 digits. Looks like it's going to be a lot of work, but let's just do this. All right, first thing we're going to do is we're going to estimate. So let's take off the decimals here. We got 113 divided by 12. Let's make these compatible. So let's go ahead and round my divisor to 10. And let's go ahead and round this one to 100. Those are nice and compatible. So 100 divided by 10 is 10. So this should be around 10. So let's find out. Okay, so if we treated these like they were whole numbers, these would be pretty big whole numbers to deal with. So first thing we're going to do is we're going to handle our decimal. Well, I do have a decimal in the divisor, so I'm going to move it over twice. So I'm going to move this one over twice, and the decimal is going to go straight up. And now I'm going to begin. So looking at, if I treated this as a whole number, this would be 11,358 divided by 1,262. Well, looking at these 4 digits, do they fit into these 4 digits? They do not. So I'm going to have to go to the very last digit. Now, that being the case, I know that my estimate, and this is where the estimate comes in really handy, I know that my estimate says that I should be close to 10. Now, if the answer was 10, then here's my decimal. That would mean there would have to be a 1 here and a 0 here. And if there's a 1 here, that means this would go into this 1 time. But we know that it doesn't. So we have to pick a lower number than 10. And a lower number than 10 that's still close to it is 9. So let's try 9. So I'm going to put 9 right here. And now I can start multiplying. 9 times 2 is 18. Put the 8 down, carry the 1. 9 times 6 is 54. Plus 1 is 55. Carry the 5. 9 times 2 is 18. Plus 5 is 23. Put the 3 down. Carry the 2. 9 times 1 is 9 plus 2 is 11. Look at that. So we zero out. And it looks like our answer is going to be 9. So 9 what? All right. How many people attended the dinner party? 9 people attended the dinner party.